that the goal, we have really two main goals for this experiment. One goal is to observe similarities between elements of the same group in the periodic table. I'll abbreviate that as PT. Another goal of this experiment is to determine your unknown solutions cation and anion. This will all make sense at the end of this pre-lab lecture video. So before we dive into what is required of this week, let's kind of just go over some new vocabulary that you may not be familiar with. So in chemistry, we have two types of compounds. We have ionic compounds and we have covalent compounds. In this week's lab, we're dealing with ionic compounds. So this is this week's lab. We'll talk more about covalent compounds in Chapter 5. But for now, let's focus on ionic compounds. So ionic compounds, as the name says, are made up of ions. And we have two forms of ions. Ions can either be cations or anions. Cations are always metals, and anions are always non-metals. If you take a look at the word cation, you'll notice that this T here resembles that of a plus sign. So all metals are positively charged species, whereas all anions, all nonmetals, are negatively charged species. An example of an ionic compound, so again, an ionic compound is made up of ions, and you have to have one component that's a cation, another component that's an anion. An example of this is sodium chloride. Now this is actually bonded. It has an ionic bond between the sodium and the chlorine, and we'll go over this in detail in Chapter 4 and Chapter 5. Why is sodium chloride an ionic compound? Well, because it's made up of a sodium ion and it's made up of a chlorine ion. Now, for the sake of completion of your notes, covalent compounds, you have a sharing of electrons between the atoms, and covalent compounds only occur between nonmetals. Now, you should be very familiar at this point with your periodic table and where your metals are and where your nonmetals are. This was covered in Chapter 1 of your textbook. Now, let's go over the anatomy of a chemical formula. So what does a chemical formula actually stand for? Well, in a chemical formula, you have symbols of the elements present in a compound, and you also have their numerical subscripts. So an example of that is calcium chloride. We'll go over naming heavily in lecture. So why is calcium, so let's dissect the anatomy of calcium chloride. So calcium chloride is comprised of calcium 2+ and chlorine minus. If it's a -1, we don't actually write 1, we just write minus. So the anatomy of a chemical formula, you have a cation, which I'm just representing as A, and an anion, and you have subscripts which with each one of these. Here we always place the cation first, then we place the anion, and when we want to figure out the charge on each of these subscripts, the X now goes to the B and the Y goes to the A. So what I mean by that is you now have AY plus and BX minus. So this is kind of just a general form of the anatomy of a chemical formula. So let's take a look at the periodic table. So you guys were all given this periodic table first day of lecture, If you don't have one, we have a stack in the lab, and there's always also one in your textbook. So pull out your periodic table. Let's set it aside while we go over some of these groups. So there are really 5 main groups that are known by name in the periodic table. Group 1A, so this group here, is known as the alkali metals. Each group has specific chemical and physical properties. So all of these compounds, with the exception of hydrogen, all behave in the same manner. Your instructor will do a demonstration for sodium metal. All group 1A elements are very reactive. They're soft metallic solids, and again, we're going to do a demonstration for you in lab. You'll see how soft sodium metal is. They react readily with oxygen. They react very vigorously with water. And as I said, all metals are cations. Group 1A in particular are always +1 cations. So all of these elements here exist as +1. Let's go on to group 2A. Group 2A are known as alkaline earth metals, not alkali earth metals, alkaline earth metals. They're not as reactive as group 1. So here we have group 2A. Again, all of their properties are very similar, both chemically and physically. And the way the periodic table was really oriented or configured was all the chemical properties of all the elements were grouped in a specific and very systematic logical manner. So all of these elements behave in a similar manner, similarly, etc. So here, group 2A, alkaline earth metals, they are known as +2 cations or 2+ cations. So if you take a look at the periodic table, really everything up until this point are metals. Anything around this snake or this ladder are called metalloids, so they can behave as metals or nonmetals. Everything else on this side are nonmetals. So the majority of the periodic table is in fact metals. So we said we have 5 main groups of the periodic table, or 5 really groups that you should know by name. The third group is group 6A, so this group right here, and this is known as chalcogens, and here you have oxygen, sulfur, selenium, tellurium, etc. Group 7A is the next group that you should know, so it's this group here. This group is known as halogens, and halogens in their elemental form are very, very reactive. So they're usually found in a combined state as negatively charged halide ions. We'll talk more about halogens, and you do have one part in this experiment that does deal with halogens. Now, the last group that you should be familiar with is the noble gases, and we'll talk a lot about noble gases when we talk about the octet rule in lecture. Noble gases, are group 8A, are these gases here. They're all gases, they're nonmetals, and they're gases at room temperature. One more thing you should note is that this word noble is not used arbitrarily. Noble gases, all elements want to have a configuration of that of a noble gas. So noble gases are stable because of their octet, because of their complete octet. Again, we'll go over this a lot more in lecture. You actually don't need to know anything about octet rule for this specific lab, but it was just good for completion of notes. So this is really kind of the background of this experiment. Please make sure you read the appropriate sections before coming to lab, and also the introduction. There's a lot of useful information with this introduction. Now let's go on and actually dissect the experiment itself. So we have 4 parts to this experiment. The first part is the flame test. This is actually a very fun experiment because you actually get to visibly see chemical reactions or differences or understanding the properties of certain compounds in lab. So the flame test, your lab instructor will demonstrate how to operate a Bunsen burner. If you want, you can also YouTube how to actually light up a Bunsen burner. But again, your lab instructor and TA will show this to you. So you're going to perform the flame test. So here we're talking about part A. You're going to perform the flame test on your 5 known compounds. You could also actually group your unknown with each of these parts so that you don't have to go back and repeat all of your experiments again. So each one of you gets an unknown. You're working in pairs this lab, but each one should have their own specific unknown. And of course, make sure you write your unknown number in your lab notebook. So how does the flame test actually work? So each ion emits a characteristic color when placed in a flame, when placed in a heat. What happens here, so each material is known to have two bands. One's known as a valence band, and the other, let's just call it an excited band for now. Really, the correct term is actually a conduction band. So all of the electrons are always in the valence band. So what happens when you place heat on an ion, you excite this electron to a higher energy state. So now the electron's occupied here, but electrons never stay in a high energy state. They actually come back down to a low energy state. And when that comes back down to a low energy state, you have an emission of light occurring. And that's when you actually start to see flames or different colored flames for this flame test. This is actually how fireworks also work. So this is really exciting to understand the chemistry behind fireworks. You're exciting an electron from a ground state to an excited state, and then the electrons always want to go back to the ground state, and upon that movement you have an emission of light, and that's what you see with fireworks, and that's what you'll see with the flame test in your experiment. Each ion emits a specific characteristic color, so this is what you're going to be noting in your lab notebook. Now, it's really important to make sure that you place your compounds. So you're going to be using wires, you're going to dip them into your solutions, and then take that wire, and you want to make sure that you put it in the hottest part of the Bunsen burner flame. So if we take a close look at this flame, notice how there are really three colors here. The hottest tip of the Bunsen burner flame is that tip right there. So that's actually where you want to put your wire. This is the hottest part, and here is where you want to place your wire with your solution. So you dip your wire into your solution, and then you put it in the hottest part of the Bunsen burner flame. Again, make sure you follow instructions very carefully. These instructions are written in a very detailed manner that you really can't go wrong in lab. Part B, so you're going to be saving your solutions from part A. When you've done all 5 compounds, and you should also here add your unknown instead of going back and redoing it. So maybe here add a test tube of your unknown. It's going to save you a lot of time in lab. When you're done with this, move on to part B. Part B, you're reacting these known, you're performing reactions of known solutions using 3 other different reagents. So what we're really looking for part B here is what we call a precipitation reaction. Precipitation reactions are defined that when an insoluble substance is formed upon a chemical reaction. For future reference, precipitation reactions are referred to as double replacement reactions. Keep this in mind for the future, because we are going to be talking about different types of reactions. So RXN is an abbreviation for a reaction. So let's actually, for those of you that are visual learners, let's actually take this and dissect it even more. So here we have 2 clear solutions, which is what you're going to have in part B. When you add these 2 solutions together, you might form a precipitate that looks like this. It could actually look even less cloudy than that. But as long as you went from clear color or clear and transparent to slightly cloudy, this slight cloudiness is what we call a precipitate. And precipitates are always insoluble substances. So the key word is that they're insoluble. You could even have more apparent precipitates, which are also really exciting in lab. You go from clear and transparent solutions to a insoluble precipitate. So here you have an insoluble substance. Regardless how much you try to dissolve it, it won't dissolve, and that is a sign of a precipitate. Oftentimes precipitate is labeled as PPT in a chemistry lab. So part A, you're doing a flame test. In part A, it should help you to identify your cation in your unknown. In part B, you will also use these results to determine the cation portion of your unknown. And how is that the case? Well, you are testing 5 known solutions in part A and in part B and in part C, and you're doing those same exact tests on an unknown. So it's really kind of a mystery game that you're playing today, this week in lab, where you're collecting data on known, and then you're comparing those results to the results that you're seeing from your unknown, and you're identifying your cation portion from part A and part B of your unknown. In part C, you're performing the halide test. Now remember, halides are nonmetals, which means you are identifying what part of your ionic compound. You are identifying the anion portion of your ionic compound unknown solution. So in part C, you're identifying again the anion portion of your unknown solution. Why is that the case in part C? Well, if you read part C, you're going to see that you're going to be using a sodium chloride solution, you're going to be using a sodium bromide solution, and you're going to be using a sodium iodide solution. If you notice here, what's the common element in these 3 compounds? The common element, or the common ion, is the sodium ion. So this is common. Therefore, we must be testing for the anion. Okay? And again, carry out your instructions very carefully. It's extremely important to not perform part C if there's a flame around you. So be very careful, because hexanes, if you remember from the MSDS exercise, is extremely flammable, and you should not have any lit flames around you. So check around, exercise, proper safety in lab, make sure your lab mates around you have the flames turned off, then you can go ahead and carry out this part. Make sure any waste from part C is actually in the halogen waste bottle. If you're not sure where the waste goes, ask your lab instructor. Now lastly, part D of your lab experiment, I strongly advise you is to integrate part D with the other parts. This is going to save you a lot of time in terms of setup. So this is basically repeating parts A, B, and C for your unknown. So might as well tack on another test tube and perform part D along with parts A through C, because part D is basically the identification of your unknown. But what I want to emphasize here is I want you to compare your observations of your known solutions to your unknown solution. And basically through the process of elimination, I want you to identify your unknown. And your lab instructor has an answer key, so make sure you write down your unknown number in your lab notebook and your answer, and check with your lab instructor. Not only identify your unknown, but I want you to identify your cation and your anion and give the chemical formula and name. All right, we have a few experimental logistics. Again, I strongly advise you to print out your pre-lab lecture worksheet. Part of your pre-lab assignment and ticket into lab is to show your lab instructor that you in fact filled out this worksheet, so might as well bring it with you in lab instead of keeping it on your laptop. Some logistics. You're going to work in pairs, but each student should have their own unknown. Make note of the safety, especially with the hexane in Part C. So I've bolded certain parts in the lab manual. Make sure you take very good care of that. As I mentioned in one of the other pre-lab lecture videos, record all initial observations of every reagent in any part. You don't have to write this over and over again. You can just write it one time. What I advise students to do is have one sheet where they record, for example, if they write reagent or initial, or how about if we just write reagent and then initial observations. So if you have a sheet in the front of your lab notebook, you write down your reagent name, you write down the observations. It's in a table format because tables allow us to more clearly see what we're working with. Then you don't have to write it over and over again. In Part A, you need to record the color of your flame. Note, this color happens in a matter of seconds. So if you didn't catch it once, do it again. This is a very fun experiment, so I really hope you do enjoy it. In Part B, you have all your initial observations. In addition to that, I want you to record the precipitate observations and clearly indicate if a precipitate occurred. Don't just say a precipitate occurred, describe what it looks like. So always describe your initial observations and your final observations. If no precipitation reactions occurred, just still describe what you see. Never write no reaction. Although in your lab manual, and this is an error that I will fix for next year, I do say write no reaction, but please describe what you see as a final observation. In Part C, I want you to record the color and clarity of the upper hexane layer. There are also initial reagents with Part C, so that's why it's really nice if you just go through the entire lab manual and set up a table with all of the initial reagents. If you're using water as a reagent in this experiment, water is a chemical and you have to write down its initial observations. Lastly, in Part D, identify your unknown, your cation and anion, and we kind of already talked about that here. So as always, if you have any questions, email me or your lab instructors. Have fun.